Good morning guys, I hope you're well. In this lesson we're going to be learning how to generate a sequence when given the nth term. So we haven't learned what the nth term actually means yet, so we're going to cover that in this lesson. I'm going to begin the lesson by asking you a question. I'm going to ask you, what is the first linear sequence that you ever learned? So just as a recap from last lesson, I'm going to remind you that linear sequence, that just means a sequence that gets increased by the same amount each term. I'm also going to tell you, you learnt this sequence when you were very, very young, probably even before you started nursery. Okay, so I'm willing to bet that the first linear sequence that you ever learned was this linear sequence. So 1, 2, 3, 4, 5, 6, 7 and so on. These are our counting numbers or the 1 times tables. When you first learned these numbers, you didn't call it a linear sequence. It's just a number that we count with, but this sequence, these counting numbers do happen to be a linear sequence. So, up until now, we've probably called these the 1 times tables, but now we're going to call them something different. A mathematician would call this sequence n. So n represents my 1 times tables. If n represents my 1 times tables, I'm going to ask you, what do you think 2n represents? So 2n represents this sequence here, my 2 times tables. Alright, so in this lesson it's going to be about representing sequences with algebra. So let me ask you a few more questions. What do you think the sequence 3n would look like? So this is a piece of algebra which represents a linear sequence. So 3n is the sequence 3, 6, 9, 12, 15 and so on. Okay, let me ask you one more. I'm going to ask you this backwards now. I'm going to give you a sequence and I want you to tell me, what do you think the algebra could be that represents this sequence of numbers? It's quite tricky, this question. Okay, so this sequence, it starts with a 4, but it's not 4n, because 4n would be the 4 times tables. Is this sequence the 4 times tables? Well, no, it's not, because the 4 times tables would go 4, 8, 12, 16 and so on. What's this sequence going up in? So it is linear, because I can see that it's going up by 3 every time, right? So would you agree that this sequence, it's quite similar to the 3 times tables, isn't it? But my 3 times tables is up here. My 3 times tables goes 3, 6, 9, 12, 15 and so on. Can you notice the link between this sequence, so my 3 times tables, and the sequence that we're looking at now? How does 3 link to 4? How does 6 link to 7? How does 9 link to 10? Can you spot that link? Okay, so we know the sequence is something to do with the 3 times table, so it's kind of like 3n. Now, did you notice the link? Did you notice that every term in the 3 times tables, every term in the sequence that we're looking at now is just one more than each term in the 3 times tables. So keeping in mind what we just said, can you come up with some algebra to describe this? So it's not quite 3n. What do I have to do to 3n to get my sequence? Well, I've added 1 to it. So we could say that this sequence 4, 7, 10, 13, 16, this is the sequence 3n plus 1. So it's the 3 times tables with 1 added on to each term. What we've just been looking at has been something that we call the nth term. The nth term is when we use algebra to describe a linear sequence. Okay, now I'm going to give you 4 pieces of algebra and I'm going to challenge you to write a sequence that this algebra represents. If you're feeling confident, I would like you to pause the video and write down the first 5 terms in each of these sequences. If you're not confident, please just leave the video running and I'm more than happy to explain them in full now. Okay, so keeping in mind what we just said, 5n, well, that number in front of n represents it represents the times tables that I'm considering at the time. So 5n, I'm going to write a sentence underneath this. I'm going to say, well, this represents the 5 times tables. I would like to think that every person in our class knows the 5 times tables off by heart by now. So this sequence of 5n represents 5, 10, 15, 20, 25 and so on. This sequence does go on forever, but my screen doesn't go on forever, so I'm just going to write the first 5 terms. Keeping that in mind, well, if 5n represents the 5 times tables, what would 5n minus 2 represent? So remember, pause the video at any time if you would like. So 5n minus 2, I'm going to write a sentence here. So the sentence I'm going to write is the 5 times tables, but I'm subtracting 2 from each term. So let's think about it. The 5 times table usually starts with a 5, but if in this one I'm subtracting 2 from each term, what should this sequence start with? Well, 5 take away 2 gives me 3. So 5n minus 2 starts with a 3. What do you think the next terms would be? 10 take away 2 gives me 8. 15 take away 2 gives me 13, and so on. So this sequence in green is the sequence 5n minus 2. Okay, this one looks a bit weird. Minus 5n. Well, if this is 5n, if 5n is my 5 times tables, what would minus 5n look like? Well, minus 5n would be the minus 5 times tables. So the minus 5 times tables would just be minus 5, minus 10, minus 15, minus 20, minus 25. Okay, if the negative 5 times tables is negative 5n, what would the sequence negative 5n minus 2 look like? Well, let's think about it. It's the negative 5 times tables, but I'm just subtracting 2 from each term. Right, so if the negative 5 times tables usually starts with a negative 5, what would negative 5n minus 2 start with? So I'm taking this 5 and taking away another 2. So if I'm already on minus 5, I need to go down even more, so I'm getting even more negatives. So that takes me all the way down to negative 7. Negative 10, take away another 2 gives me negative 12. Negative 15, take away another 2 gives me negative 17, and so on. So this green sequence is the first 5, these are the first 5 terms in the sequence negative 5n minus 2. Okay guys, for your classwork today, I'm giving you the nth term. I'm going to challenge you, for each of these nth terms, I want you to write the first 5 terms of the sequence that this piece of algebra represents. So it's just like what we just done. So please find your worksheet attached for you on Google Classroom. All your answers are on there to help you as well. And if you get stuck, please just send me a message on Google Classroom and I would love to help you. Alright, good luck guys. Thank you very much.